In computing, there is a balance between accuracy and performance. To try to establish a balance, a group came up with a standard type called the floating point, which is defined by standard IEEE 754. This takes a number, like 0.1, and represents it in binary representation. As you might have guessed, since 0.1 is a repeating decimal in binary, the floating point representation will limit 0.1 to a certain number of decimal places. Its representation is shown below. Sign, exponent, mantissa. 0.0111011001100110011001101. The 32-bit floating point type represents our number in scientific notation, which you may have seen shown as 1x10⁴ in the past. For binary, the difference we use x2 since it is base 2, so an example would be 1x2⁴. Therefore, the floating point binary representation is split into a few pieces. The first digit is the sign, so it is 1 if negative. The next 8 digits are the exponent, i.e. the number we raise the x2 to. The next 23 digits are the mantissa, which is the number that is multiplied by the x2. This gives us the balance of having a large amount of numbers we can reference, while still having a good performance. Back to 0.1. In our floating point notation, we limit 0.1 in binary to a certain number of decimal places. The mathematical notation we have conveyed into binary is shown below. Sign, exponent, mantissa. 0.011110011001100110011001101. Hashtag is the equivalent in mathematical notation of 1.6000002384185 to the power of -4. If you try to put 1.6000002384185 into Google, you'll get a value of 0.100000000149. As we've said, since binary represents numbers differently, meaning certain numbers are repeating decimals when they wouldn't normally be in base 10, when we try to present them in binary, we have to round them to a certain amount of decimals. This rounding then shows up when we go back to base 10, meaning our once exact base 10 number is now 0.100000000149. Now if we try to use this in a calculation, we end up with a rounding error, which is why console.log 0.1 by 0.2 returns 0.020000000000000004. Can I avoid it? Hashtag. Some languages have a decimal data type, which is a way to solve this issue. However, you don't necessarily need this. For simple errors like this, you can round the number down to your required decimal length. Overall, this is an interesting example of how computers attempt to balance speed with performance.